or that could be a problem. Questions on the piecewise? Wow, thank you, Mason.
Oh, gotcha.
Big question is, did you want me?
What?
There's an awkward silence. Kind of felt bad about myself there. All right. In domain and range, the thing I want you to know about domains and ranges is that domain means X. Range means Y. If you don't know that, you're in deep doo-doo. And now, I would like you to take your calculators out, type 5a into your y equals, and look at the picture. I think that's what it looks like. Somebody check for me.
Yeah. Oh,
Okay, so let's talk about domain and range. Are there any x values in 5a that if I shove a number in, it causes a problem? Like, for example, am I dividing by 0 anywhere? No. Am I square rooting a negative number? No. So that's not, I'm not getting any issues because I don't have any of those kind of problems. Those are domain things. If I divide by a number that I plug in that gives me a 0 on the bottom, that's a problem. If I try to take a square root of a negative number, that's a problem. That's not happening in 5 at all. So for your domain, what I would tell you is that your x is all reals. Now, if you wanted to write it in interval notation, you could do this. Remember, you can never bracket infinity, but anything from negative infinity to positive infinity works. There are no issues. So domain means the x's. There are no problems shoving in any x. You can do whatever you want to. Range means the output or the y values. Look at the picture. Are there any y values that are not present, Joe?
Anything above 1.
Excellent. Nothing above 1. The picture will never produce any y values up here. It never goes above 1. So we're going to say that our range is when y is less than or equal to 1. It's the highest point on the graph. Never goes above it. If you wanted to write that in interval notation, you would write it like this. Bless you. And since I can get a 1, I would bracket the 1. So the x's, no issues. I can go as far as I want, left or right. The y values never go up past 1. You can get a 1, but you can never go past it. That's the range. I'm I'm going to pause, so you're going to try letter B. I'm going to give you 4. So now I'm looking at my window and I put this part B in. And maybe I'm going to go back to negative 10 and 10, see what happens here. Negative 10. Oops. My bad, sorry. Negative 10 and 10.
Oh, wow.
Yep.
That's kind of weird.
Yeah. Takes one to know one.
It does.
So here's what's going on. I'm going to hide this for a second. And I'm going to draw this picture to the best of my ability on the whiteboard. Here's my graph. And it looks like when I graph this thing that part of my graph looks like this. And the other part over here looks like this. And then there's a part over here that goes like this. No, that sucks.
Mine is like a straight line. Mine doesn't go up forever.
Yeah. That's because it's a calculator.
Mine looks like it connects. Yeah.
Yeah.
Goes up, stops.
Just telling you, that's what it looks like. So here's what I want to know. First thing I want to know is, why is this part of my orange graph not touching the y-axis? What's that called?
A limit.
A limit? There's another word?
Asymptote.
Asymptote. Very good. Again, it's an asymptote. So right here, we have something called an asymptote. It's something you get really close to but never touch. And even though you can't see it, there's another one right here. That's why this orange graph down below is not touching it, and off to the right, it's not touching it either, and there's a gap. So the question is, first of all, we know that this is a 0 for that x value. What's this x value over here?
Could be like
I don't want the could be. I want to know exactly what it is.
2.
It is 2. Did you just guess?
Nope.
How'd you know that?
Table on my calculator.
Table on your calculator. Okay, so one strategy is a table on your calculator. But I want you to notice something up above. Do you see the bottom?
Yes.
There's some variables in there, right? What's going to cause a problem in a fraction?
0 on the bottom.
0 on the bottom. We don't want this bottom to be 0. So if I looked at this bottom, and I said, hey, where is x squared minus 2x equal to 0? And then I factored out an x. Now you know that 2 and 0 would make the bottom 0. 2 and 0. That's the algebraic way to see which x values cause problems. In fact, these are the only x values that cause any issues for us. And x is the domain. So if I'm talking about my domain, I would tell you that the x's can be anything you want it to be. Anything. Except for 0 and 2. The way that I would write that is x not equal to 0 or 2. This is one way to write it. But if I had to do it in interval notation, which you may be asked to do on the test, in fact, I'm pretty sure you will be, you would write it like this. Negative infinity up until 0 with a parentheses because you can't use 0. Union 0 to 2 is fine with a parentheses. You can't use 2, but I can keep going after that, so another union 2 on forever. So there are 3 parts. I personally think that interval notation for this particular case and domain is ridiculous. when you can just say x can't be 0 and 2. But you may be asked to write it that way. And the way I remember it is there are 3 sections. 1, 2, 3. Which means I have 3 pieces. 1, 2, and 3. Look at the y values. Notice how anything from the x-axis and up is fine. And anything below this value here is fine. But there's a space in the middle that you can't see. There's nothing there. So the range from our table, from our graph, you would find can go from way down below, which is negative infinity, up to and including whatever point this is for a y value. What point is that? It's not 0 because that would be on the x-axis. It is a negative number.
Negative 10.
It is negative 10. Very good, Jessica. And then there's a gap. So we put a union. So there's a gap. And I never hit the x-axis. So I put parentheses, 0, and that graph goes forever up in the y direction. And we can never include infinity, so we always have a parentheses there. So I would tell you that the range in this particular problem, you definitely need to take a look at your graph or the table. The domain, there is an algebraic way to solve that. But you could also look at your picture.
Is it just a coincidence then that the top, the numerator is 10 and the...
It is not, in fact, a coincidence. The top will never be anything but 10. So that is one of the reasons why there's a negative 10.
Wait, what?
Yeah, but how does that have anything to do with the range?
It has to do with the range because when you're dividing by negative 1, that's how they get the negative 10. And so the bigger the number on the bottom, the smaller the overall fraction will be. For example, if I had the denominator being 100, I would have 10 over 100, which would be 1/100th. Know what I mean? So the biggest value that the numerator will ever be is 10. And when you divide by 1, that's how you get 10 or negative 10. And then as you divide by much smaller numbers, like for example 0.4, this is the 0.4 right here, but you're dividing by 0.4 being plugged into the x value, which actually, when you square it, is 0.16, so on and so forth. Best, again, to just look into the table. You can kind of see that, or on the graph. Out of all the stuff we're doing today, probably letter B here is the most complicated. What is going on here? Oh, okay. In letter C and letter D, my opinion, I think that it's best to just take a look at the picture. If you were in my Algebra 2 class last year, we talked about something called transformations, which is how you change something around. So you might recall that if you're talking about square root graphs, that the general square root graph starts at the origin and goes off to the right like that. So here's a picture of the general square root graph, which means that the graph that we're seeing here, this picture, has actually been moved to the right 3 units. 1, 2, 3. So it actually looks like this. Now you could graph this on your calculator, you could use a table, but if you have an understanding of transformations, it is much faster to just know that it's been moved to the right 3. Why? Because now I can tell you that my domain starts at 3 and goes to the right forever. I can tell you that my range starts at 0 on the x-axis and goes up forever. So domain means x's. I'm just to the right of 3. And range means y's above the x-axis. Part D is a little